All right, guys. So we're gonna be doing what it says up here today. We're gonna be finding the parts of rational functions, those things down there, finding their y-intercepts, their vertical asymptotes, x-intercepts, and holes, so that we can graph them. That's pretty much our goal for the day. Um, Tomorrow we're gonna actually start graphing them up, and I think that'll pretty much close out the chapter after that. So we'll be done, I think. Let me see. I'm pretty sure of it. Yep, we should be good after that. No, I don't have a final. We'll have a test on this stuff, but no final for you guys. Now we've talked about one special type of rational function, which you don't need to write this, but we've talked about this, right? I think I'm using different letters, but oh well. That one's kind of worth talking about. It's a nice way to introduce some limits and how they have asymptotes and things like that. But we're going to talk about just rational expressions in general. So this is just like one special kind of rational expression here. We're going to talk about graphing things like this one today. Or maybe this one, right? So a more general approach for a greater variety of types of rational expressions. This is a good lesson for those of you guys that plan on going into calculus. A lot of properties about these functions are useful in calculus, actually. So something I wanted to share with you guys here was just what these functions could look like. Let me zoom in a little bit. So here's the graph of one of these functions here, okay? You'll notice that it has a vertical asymptote. So it's not too uncommon for them to have a vertical asymptote. It's pretty common, actually. What else? Let me find here. Let's see if there's one here that has a hole on it somewhere. I don't like the way they're showing it, but they can actually have holes. So usually, that dot you see there, I think that's supposed to represent a hole in the graph. It's like just a blank spot where the function doesn't exist. We'll talk about how you can find where those are at today as well. I don't like how they showed that. I would prefer them to use an open dot, but I'm not too sure why. I thought it did that actually. Now I'm a little confused. Let's see. And they can also have horizontal asymptotes. Sometimes, not always. So there's just every function is going to be a little bit different, but those things that we're looking for today, horizontal asymptotes, vertical asymptotes, holes, y-intercepts, those are things that we want to be able to find. And then tomorrow we're going to take all that stuff, put it together to learn how to actually just get a rough estimate of what the graph might look like. And that'll pretty much be it. Okay. So let's begin. So how do you find a y-intercept? We've done this many times this year in various circumstances. The answer is always the same. You plug 0 in for x. That's it. You plug 0 in for x. So we're going to do that today, but you'll kind of see that there's a little bit of a shortcut there, which we'll add to in a second. Our notes. So let's do this one really quick. So go ahead and write down number 1 there. Our directions are going to be to find the y-intercept. And I'm going to cheat a little bit here. Can you guys put a +1 on the end? Yes, you can. You will. All right. So I mean, pretty straightforward. Plug in 0 for x, right? So anything here with a 0 next to it is just going to go away, right? Because 0 times anything is 0. And so I'm left with 3 over 1, which is 3. Okay, so it would touch the y-axis at 3. Mm-hmm. There you go. And that's the shortcut. So basically, you guys don't need to do that work, okay? All you need to do is look at the number on the top and the bottom that don't have an x and make a fraction out of it, because anything that does have an x becomes 0 if you plug in 0, okay? Now, let's back it up a little bit, though. Let's say, and you don't need to write this if you don't want to, but let's just say I had this instead, if I didn't have that +1. If I didn't have the +1 on the bottom, instead of being 3 over 1, it would be 3 over what? It would be 3 over 0, right? Because you're plugging in 0, and all that's left on the bottom is 0. And that, sometimes people think it's 0, but it's not. That's actually undefined. And what that means is it doesn't touch the y-axis. Okay? So it could be possible that it doesn't have a y-intercept. All right? So that's pretty much the gist of it there. Yeah, I put U, but if you don't know what that means, you might want to go and write it out as it means undefined. It means there isn't one. So now that I'm bringing up the actual problem here, let's look at the answer here. So here's the graph, and you guys can see why this one would, the original problem would not have a y-intercept, because you guys can see there, that's a vertical asymptote. It can't touch the y-axis because the y-axis is a vertical asymptote. Yeah. Well, this is the problem that I wrote originally, and for that one, which I didn't graph for you, it would touch the y-axis at 3. But I went back to this one. Remember I took the +1 off? That changes what the graph looks like. So this one would not have a y-intercept, but the one that I wrote over here would. And I don't have the graph to show you on that one. But I mean, if you want to know something about it, we know this much. It would touch the y-axis at 3. But this one does not. All right, so that's pretty much the gist of it. Pretty straightforward. Why don't you guys, you don't need to write this exactly, but just think for a minute about what the answer would be. What do you think, John? What do you think it would be? -3/4. So the answer would be -3/4. So you don't really have to do any work there. It's just look at it, right? And if we were to graph this one, you know, this right here is about 1, so -3/4 would be right about there, and that's where it touches the y-axis. Okay? So that's pretty much the gist of it. The rest of the day, we're going to be focusing on the other 3 things that we wrote at our introduction today. So we took care of the y-intercept. That's pretty chill. But the vertical asymptote, x-intercept, and holes, we're going to kind of look at those all together at once here. because they kind of all go hand in hand. If you find one, you can kind of end up finding the others, basically. So,
The vertical asymptote is going to be x-intercept, finding the x.
can you say that again?
Is the vertical asymptote same thing as finding the x at the same time?
No, no. They are different things, but the way that you do them is so similar. We're just going to do them all at once. And that's what we're about ready to tell right now is how do you know when to do which. So let's just review something. You don't need to write this. I just want you guys to watch for a second. All right. So if x equals 4, then what do we get? That's the final answer, right? So if you plug in 4, on the top you get 0, and on the bottom you get 9. But anytime you have 0 on the top, the answer is just 0. Okay? Now this is my y value, right? So when I plug in 4, I get y equals 0. You guys good? Now, what do we call the points where y equals 0? X-intercepts. So we found the y-intercept, right? The y-intercept is where you plug 0 in for x, right? But if you want to find your x-intercepts, what you're going to do is you want to find out what you would plug in to the top here to make the top equal 0. Because if the top equals 0, then the whole thing equals 0, and that's an x-intercept. So what that means is that this would be an x-intercept. Okay? What about if x equals -5? What's the answer? That's right. And what is that? That's undefined. And that means my y value at that point is undefined. Where does a rational function not touch something? At an asymptote. So that's your vertical asymptote. So let's get these two things straight, okay? Whatever makes the top of your fraction equal 0, that gives you an x-intercept. But whatever makes the bottom of your fraction equal 0, that gives you a vertical asymptote. So whatever makes the top equal 0 is what gives you an x-intercept. That's where it touches the x-axis. But whatever makes the bottom equal 0, that's where you're going to have a vertical asymptote. So for instance, if the graph of this thing, you don't need to graph this, but you can just watch. This thing is going to touch the x-axis at x equals 4. And then I'm going to have a vertical asymptote at -5. Does anybody know what the horizontal asymptote would be? Probably not. That's okay. Huh? No. Good guess, though. I think this was from Monday's lesson, if I'm not mistaken. No, this is a little bit different. It's a little bit different. It's from Monday's lesson. Well, it's okay if you don't know for now. The answer is 1. But anyway, I don't want to distract you too much with that stuff. So I know it should touch the x-axis here, and I know that these are my asymptotes. So this graph would look something like this, basically. Does that make sense? So there's our summary. But before I go any further, let's do one more. And once again, you're not writing this, you're just watching. I'm going to summarize this for you guys in just a second. But let's say I had this. Okay. What would make the top equal 0? One and -2, right? So then those are both potentially x-intercepts, right? What makes the bottom equal 0? Okay. -2 and 3. So based on what we've already learned, then the x-intercept, it would touch the x-axis at these 2 points, and then we would have a vertical asymptote at those 2 points. Now, if I were to try to graph this, let's see what happens. We have 1 here, -2 here, so it's going to touch there and there, right? And then I should have a vertical asymptote at 3 and at -2. Does anybody see an issue? Huh? Why not?
There's 3.
No, that's okay. So here's the thing. Can you actually touch, can a graph touch its vertical asymptote? But I said that was one of the roots. I said that's where it touches the x-axis. So that's an issue. You can't have a root where there's a vertical asymptote. And so these guys basically make a deal. They'll say, hey, I won't be a root if you won't be a vertical asymptote. So they both just agree to ignore each other. Okay, so what that is that point, it's not a root, it's not a vertical asymptote, but I don't know what this graph looks like. Let's just say it looks like this, okay? But at x equals -2, it's not a root, it's not an asymptote, but you know what it is? It's a hole. The function cannot exist there because if you can't plug in -2, you're not allowed to. But it's not going to be a root either. So what that does is when you have the same factor on the top and on the bottom, it's not a root, it's not an asymptote, it's not a root, it's a hole. Okay? So at x equals -2, we would have a hole. So there it is. So let's go ahead and summarize these facts now. See how to find, and this is where you guys would want to start writing, how to find x-intercepts, vertical asymptotes, and holes. Okay. All right. So first, you want to make sure you factor the top and the bottom. Okay. Now I didn't mention that on the last page, but you do need to do that first. So you will factor the numerator and denominator. And then take the numerator, the top, set it equal to 0 and solve. That gives you the x-intercepts. So take the numerator, set it equal to 0, and solve for the x. So in other words, find those x values that make the top equal 0, and you've got your x-intercept. To find your vertical asymptotes, You take the denominator and set it equal to 0 and solve. And then finally, if you need to find the wholes, what you do is you look for the factor that is the same on the top and bottom. And you set that equal to 0 and solve. Now, a rational function, you guys, may not have some of these things, okay? So it may not be possible to set the top equal to 0 and solve. I'll show you an example. We'll probably see an example like that today. But it may not be possible to set the top equal to 0 and solve. That would mean that there's no x-intercepts. It may not be possible to set the bottom equal to 0 and solve. That would mean that you have no vertical asymptotes. And it may also be the case that there's no factors in the top and bottom that match. In that case, that function would not have any poles in it. Okay? So none of these things, it's not like every time you have a rational function is going to have these things, but we're always going to look for them. Okay? So that's all we're doing for the rest of the day is we're going to be finding those three things. And we'll just do a bunch of examples, kind of see little things that pop up along the way. All right. So let's do some examples here. Like that. Okay, so the directions here, guys, are going to be to find the wholes, vertical asymptotes, and x-intercepts. So go ahead and write down number 4, and I'll put the directions up too. Okay, so we got to factor first. Okay, factor the top and the bottom. So on the top, I see that there's a GCF there. So if I were to take out a GCF, I would have x times x squared minus 4. On the bottom, I see there's another GCF. I see I could take out a 4. That would leave me with x squared minus 5x plus 6. I'm still not done factoring though. The top, that's a difference of squares, right? And so that's going to be x plus 2 and x minus 2. And on the bottom, we would use the box method for that to factor it. I think it would be x minus 3 and x minus 2, if I'm not mistaken. Okay, so that's the first thing you guys got to do is you got to factor it first. Okay, so let's go ahead and start by looking for the wholes first. That's a good place to start because if you do wholes last, you might make a mistake. So it's good to start with the wholes. Do you guys see where there may be a hole? There it is. That's a hole right there. So we're going to cross that off, right? Because we don't want that to be part of our function anymore. But we are going to take that piece and we're going to set it equal to 0 like that, and we're going to solve. And so I get x equals 2. So this graph has a hole in it at x equals 2. We don't know what the y value is for that. Well, there is no y value at that point because it's a hole, but we don't know like what y value is getting close to there. But we just know that there's a hole at that point. So we have no idea how high up the hole is, but we know somewhere on this line there's a hole on our graph. Okay. All right. The next thing we're going to do is let's go ahead and find our x-intercepts. So to find your x-intercepts, you're going to set the other two factors equal to 0 and solve. So we have x equals 0, and we have x plus 2 equals 0. Okay? Now you don't have to show your work for this, but on your notes it's nice to see it worked out in case you come to it later. But here's our two x-intercepts. So now I know that I've got, it touches the x-axis here, and it also touches the x-axis here. So I found where the hole is going to be. I'll just put an H here to represent somewhere at this point where x equals 2, there's going to be a hole on my graph. And I know that it's going to touch the x-axis here. And then number 3, we need to find our vertical asymptote. And that's where you take the bottom and you set it equal to 0. Now, you're not going to set the 4 equal to 0 because there's no x there. You can't say 4 equals 0. It doesn't make sense. But you can say that x minus 3 equals 0, right? So we're going to have a vertical asymptote at x equals 3. So let's draw that on there too. Well, you aren't drawing the graph on your paper. You can, but it's not necessary. This is just to kind of show you guys what we're doing. We're going to get into the graphing stuff tomorrow, but I'm just kind of warming you up to it. So once again, first step, factor it. Step 2, the one that cancels on the top and bottom, that's a hole. To find your x-intercepts, set the factors on the top equal to 0 and solve, and to find your vertical asymptote, set the bottom factors equal to 0 and solve. Now I'm going to go ahead and show you the graph, and you guys can kind of see all these things that we just found. So you guys can see here the line comes, it hits that root, it comes back down, hits that root, and then it comes down. You guys see that dot there? I would much rather they had made that an open dot. Because the graph doesn't exist there. You guys agree that x equals 2 here, right? Now, we had no idea that it was going to be down here. It could have been up here or anything, but we'll get to that later. But for now, that's where the hole is at. And then we have our vertical asymptote here, and then the rest of the functions over there, but we don't know anything about that right now. So that is how you find those 3 things. So factor it. Holes are the ones that cancel out. X-intercepts come from the top. Vertical asymptotes come from the bottom. Okay, so we'll do a little bit of a guided practice here to kind of warm you guys up to this stuff. All right. So go ahead and factor it. This is a guided practice here. Go ahead and factor it. This one is very simplistic. I don't want to say simple, meaning it's not necessarily easy to do, but I'm saying that it's simplistic. There's not much to this one. So check your answer to the neighbor. I'm going to call on you to share out what you got for the factorization. How many of you guys ready for this? I might be going too fast. You guys ready to share out yet? No? How many of you guys just need more time? Ah, you're ignoring me. So I'm going to try my luck here. I'm going to say, Gabrielle, what did you get? To factor it.
2 and parentheses x minus 2.
That's it. That was it. There's nothing to that one. That's all you had to do for that. Good. Okay, so my next question I'm going to ask you on the fly here. Amaya, does this function have any holes? No. I can't cross anything off the top and bottom. So we're going to say, for holes, we're going to say none. This graph has no holes in it. Bless you. Sit lolly. If I wanted to find my x-intercept, what would I set equal to 0? Okay, why don't we all take a minute and think about it. I'll give you a... So if you want to find your x-intercept, you set the top factors equal to 0. Now, this is the only one I'm going to set equal to 0. You don't set a number equal to 0. That won't work. It has to be something with an x in it. So we would have an x-intercept at x equals 2, which means that it's going to touch the x-axis somewhere right about there. Kalani, where would we have a vertical asymptote? That's right. You set the denominator to 0. So I'm going to take that x in the bottom there. I'm going to set that equal to 0. So we have a vertical asymptote at x equals 0. You know, we can also find our, well, no, we can't. What's the y-intercept here, you guys? And that's from the beginning of today, remember? Where you plug in 0? Huh? No. No. Undefined. And that, why is that undefined? Because look where my vertical asymptote is. My y-axis is the vertical asymptote, so it can't have a y-intercept. The horizontal asymptote would be at 2. That's from Monday's lesson. So now if you don't remember that, we'll chat more about that. But there's the graph. Okay. All right, we're just going to do a couple practices today. That's it. This is all we're learning. If we have some extra time, I'd like to review Monday's lesson with you a little bit more, but I would like to make sure you guys are getting this stuff here. So, all right. So let's go ahead and begin here. So I'm going to ask. I think you're probably sleeping. Elijah, what's the first thing I need to do, bud? Good. So go ahead and factor that thing completely. Give you guys a few minutes. Go ahead and factor it completely. So Gabriel, what'd you get? Oh, you're already done? That's cool. I just want the factor form. 2x minus 3? Like this? Is that right? Oh, and then we can go a little bit further. Did you factor it like that? No? Okay. Interesting. But you still got a hole in a vertical. I'm curious how you did that. But we do start with the GCF. Castillo, how about you, bud? Did you get that polynomial factor? That trinomial? You got it? What did you get? X plus 1 and x minus 3. I'm going to reverse it, but x plus 3, x minus 1. But you're good. You picked the right numbers anyway. Okay. So now I'm going to ask Steve, what do I look for first, Steve? We look to see if there's holes, okay? And then I'm going to ask Amanda Deep, how do we know if there's holes or not? If you have anything that cancels on the top and bottom, right? So, Braden, does this thing have any holes? No. No, there's nothing that cancels, so we can't do any holes. So we're going to say none. Okay, so Nylea, how do we find x-intercepts? Huh? Good. Set what equal to 0? Oh, good, the top, right? Now, can we set the top equal to 0? No, it doesn't make sense, right? I mean, you can write that, but it doesn't make sense. And what that means is there's no x-intercepts either. No x-intercepts. So it doesn't touch the x-axis. It doesn't have any holes. Nicole, what do I need to do next? Vertical asymptote. Good. And Madison, how do we find the vertical asymptotes? We set the denominators equal to 0. So I'll give you guys just about, so what we just said was that now we're going to find the vertical asymptotes. And you do that by setting the bottom equals 0. So I'm going to let you guys do that. I'm going to give you like 30 seconds, and then I'm going to call and you share out your answers there if you haven't already got it. Function. -3 and 1. So all we know about this graph is that it has a vertical asymptote here. Oh, -3, not +3. Sorry. Vertical asymptote here, vertical asymptote here. But we can also find the y-intercept. What would the y-intercept be? 1 over -9. So it's a negative number, so it's below the y-axis and it's really small. So it's going to be right about there. Let's go ahead and see what the graph looks like. And there it is. Kind of hard to see, but it kind of curves up like this, and then it curves, makes like a U shape here, and it curves like that. Okay? What were you copying? The graph? Okay, sure. Take your time. So here's the factorization. There's no factors in the top and bottom that are the same, so there's no holes. If you set the top equal to 0, I left one out. There should be another hole. There should be 3 x-intercepts. 3, 1, and 0. And then there's 2 vertical asymptotes at 2 and -1. And then I got a graph there to kind of demonstrate all those things. Mm-hmm.
Yes.
I do.